So our time's a little off. If you're here for MLKit, great, except that I'm giving that presentation, so maybe not so. This title is MLKit, or How I Learned to Stop Worrying and Embrace Our Digital Overlords. So obviously, who am I? Yeah, that is me, right? I got to double check. I work at Capital One. I'm a mobile platform architect. A lot of fancy words for breaks code. I also consider myself just a dev. So that's how I refer to myself a lot of the time. I'm a founder and co-organizer of GDG Wilmington, one of our other organizers here as well, beneath. That's in Wilmington, Delaware, just for those who may think that that's elsewhere. I'm one of the GDG Northeast mentors. We had some great mentors in the past, and I'm hoping to help there. I'm also an avid video gamer, so you'll notice that in addition to my Twitter handle, I'm still holding on to Google+. I also have my Battle.net ID at the bottom there. If you take off the hashtag and the number, you can find me on PSN, Switch, and Xbox Live. So on to why you're here. Well, actually not yet. So MLKit stands for machine learning. And what is machine learning? Well, machine learning is simply one of the many pieces underneath the artificial intelligence umbrella. And it's specifically focused on the subset of problems whose solutions are believed to require human reasoning or thought, human intelligence, basically. Machine learning provides solutions by running data through a series of mathematical algorithms. It's the algorithms that are constantly refined and updated as more data is processed. With machine learning, developers don't actually produce the code for the domain, but rather the mechanism designed to create and update the underlying mathematical algorithms that help solve the problems within said domain. So there's no direct coding of a specific domain. It's more generalized to solve the problem that they are designed for. Models are typically designed to either uncover patterns within unstructured data. So a lot of data is thrown. It's sorted out through either supervised or unsupervised learning. In this case, typically large data sets to uncover patterns are done with unsupervised learning. There is no assumption on the data that the system is being given. Whereas supervised learning, it's an attempt to classify data and achieve producible and inferable results from these algorithms. Regardless of which mechanism is used, machine learning takes a lot of time, processing power, and data. And it means you can't run Bitcoin while you're doing it. So it's great that we have MLKit to come to our rescue. And with MLKit, we get 3 of Google's existing APIs. There's Google's Cloud Vision API, TensorFlow Lite, and the Android neural networks for mobile. It brings all 3 of these together into a single library, which lowers the barrier of entry. So it means that your apps can now use AI and machine learning within their code. And depending on the portions, you can either choose to execute on the cloud, in the cloud, or on the device. And this level of flexibility allows you to include functionality even when the network isn't present. Granted, you get a slightly degraded experience of what's possible at that point. SDK is available through Firebase, making it easier to jump on the Firebase bandwagon if you haven't yet. Platform offers storage capabilities, performance monitoring, and analytics. And each of those is available to help enhance the MLKit integration and experience, even to leverage the ability to deliver some of these models. Including the SDK are 5 easy-to-use and ready-to-use APIs, with more along the way. We'll talk about those APIs in the next section. They've listed it as being ready for production use cases. And that means that you can integrate this today and release it to the public. But the beta naming, that's confusing a lot of people. When Google betas something, typically it's to let people know that there is no stability in the APIs. So it's possible that the way in which you call functionality today may not be the way that you do at release. It also means that there's no service level agreement or SLA. So it could take 10 seconds, it could take 10 years. There's no guarantee that these services will be up when you need to use them. And that's another reason why it's considered a beta. And of course, the deprecation policies, they may choose to remove portions of functionality at release. And that's, again, something that this beta nomenclature affords Google. So let's meet the the APIs, the digital overlords, as I called them. So first up, we'll go with image label. Image label is the API. It's capable of executing either on-device or within the cloud. It's a ready-to-use functionality, provides a recognition and identification of the contents inside an image, be that people, activities, places, entities that this API can detect without anything other than the image itself. So simply feeding it live data gets you access to information about what's in that image. Each identified element is given a confidence score, and that score is used to denote how probable that label applies based on previous network integration, based on the previous algorithms. And some use case where you might want image label generation is for automatic metadata. So finding out what's inside an image without having to manually have someone read it and type the hashtags for it. Content moderation, filtering out or flagging imagery that may be inappropriate for your applications or users. Image label, the image label API lets you do this simply by passing in an image. Now, as I mentioned, and with the APIs that are on cloud and in the cloud and on the device, I provide a little sort of comparison here. Some differences, Page will hopefully provide better insights. Tried to do that. Image labeling on device includes about 400 plus labels. They're commonly encountered items. The cloud has 10,000 plus specific. Obviously, I skipped over the top one. Pricing, obviously, it's free on device. Use the device as much as you want, but if you go into the cloud, you're going to start paying after you make 1,000 calls to the API. Now, the API in this case is the Cloud Vision API. It's shared with pretty much everything within the kit. So it's not 1K of just image label and the other 4 APIs. It's 1K of all of them combined. So keep that in mind. So if you make 1,001, that's when Google will start charging you, and that pricing varies based on how many calls you make in any given month. So every month it resets, you get 1,000 for free, and that's how the pricing works. I'm just the messenger on that one, so I have no say in that. Configuration options. So you can actually choose what threshold value a label should come back as. So if you're getting a lot of values or not enough values, you can change that value. The default of threshold on device is 0.5. So with a 50% confidence level, you'll get back tags that apply from a top down, most confident to least confident. There is no way to change that with the cloud. Instead, you can change the number of results you get. And that's why I mentioned the caveat, because on device, you'll never get more than 10 tags for a simple image label. Whereas on the cloud, it defaults to 15, and you can set that. They mentioned that the cloud functionality of this API specifically is in preview, and that if you are going to production with this, and specifically with cloud functionality, you should consider using Cloud Vision API until they go release MLKit. And that's going to be the same for everything going forward. With anything that has an on-device presence, they would prefer that you use Cloud Vision at the moment. Of course, unless you're willing to help solve some of these beta side issues. One of the things that I do have here is, nothing apparently. I'll have to reconnect that. Give me 1 second. But I do have a device running the example, and so I can show you what vision would look like in a live experience here. Give me 1 second. No, this is Visor. So Visor is basically, it allows you to take a phone. I'm gonna wipe my phone across the audience here, in that I'm gonna take a picture of the room, and hopefully we'll see tablecloths, rooms, chairs. And so this is live. This is doing live data. It's all on device. As a matter of fact, I can even go one step further and turn off LTE data to show you that as I move around the room, the amount of data coming back, there was fun in there. I didn't know this was fun. Are you having fun? I hope you are. A musical instrument. It's seeing the. I think maybe the remote. It thinks that, guys. It's a mobile phone now too. So as you can see, by default, the confidence level and the information that you get when you're on device is not as robust. And of course, you wouldn't want to do in the cloud with live detection. If you're streaming actual images, you're probably going to want to be more conservative and not send every stable frame that you get up to a server to figure out what's going on. Yep, VYSOR is correct. Of course, that's. Puts me at a disadvantage. Now I got to go find the notes. So Visor itself, it's simply an application that allows me to show you what's on my phone. So it lets me remote the display onto my desktop screen. You can definitely interact with it. We can discuss Visor a bit more later. All right. Of course, it has to do that, right? So that's image label. Coming up next. There we go. Is text recognition. This is another one of those APIs that can execute either on the cloud or, well, I say in the cloud or on the device. It's pretty straightforward. Text recognition, it sounds pretty straightforward. In actuality, pulling data outside, pulling data from an image into text is actually much, much harder than you might think. It also goes through and attempts to build language structure from those images as well, not just the individual text elements, but also the words, paragraphs, sentences, blocks of text. And like I mentioned, some of these use cases, translation, you can take one language, translate it to another. Accessibility, make things that aren't accessible for some people or who have issues obtaining access to that data, make it a little bit easier through translation, as well as tracking things in the physical world that might exist. An example of that might be the numbers on a train, being able to physically track that based on images, as opposed to other easier methods, probably. So the comparison here between on-device and in the cloud, the pricing, same as last time. The processing, though, on-device is real-time, and in the cloud, highly accurate. Again, the reason you don't want to keep sending those images is because Google will gladly take your money and not worry about it. Keep in mind that if you are using this, the reason you're doing it is to be more accurate, to make sure that you're getting the right pieces of data that you need. On device, offline, you won't have access to the cloud anyway, so always providing some level of experience on device, if possible, is something you should strive for. The number of segments, I mentioned how it tries to reconstruct language, syntax, and patterns. So on device, you'll get four levels deep. They'll recognize the text, all the text, blocks of text, lines within that text, and each individual element. That element is typically like a word but they don't call it a word. It could be a single character. They're not sure. It could be any level. Whereas in the cloud, they can get a little bit more in-depth. They can recognize text, block, paragraph, word, and symbols. Symbol because it could be in any language. As the recognition on device is limited to Latin-based characters, whereas broad range of characters and languages, not just Latin-based characters. So you get different alphabets, you get different translations. The other thing to call out here is that there's two different types of mode. There's sparse text, which is basically stuff you would see on a bottle or on a billboard, and then there's document text, which is typically walls of text, if you will. The cloud is the only place where you can handle document text, large, densely packed pieces of information. And I'm going to show these all off after I finish all of them. So we'll move on to the next one. Face detection. It's important to stress that this is not facial recognition. It is face detection. I don't know who you are. I know that you have a face, whoever you are. This confuses a lot of people. It's something to make sure that you're doing. And it's identify facial features and expressions. So find out where the eyes are, whether or not those eyes are opened or closed, whether or not they're smiling, whether or not they're happy, what mood the person might be in based on that. And so this is on device only, because and it's done in real time, and it can track people and faces across frames. So it builds general structures of a person's after they identify the eyes and the location. Since if you're doing continuous video, they can track where that has moved between frames because of the bounding boxes that were built in the previous frames. It's really great because generating avatars, responding to expressions, and making selfies more aware. I think it's really just so you can have Snapchat overlays when you take pictures. But is there? Yeah.
It does sentiment recognition on the face stuff, but does it do it on text as well?
I'm sorry. Does
Sentiment recognition, like does it like on faces? Does it say smiling? It does.
It does. So the expression, yes. So it does tell you whether or not they're smiling. I think they call it happiness.
Yeah. Does it do that for text? Can it like does it also analyze text for sentiment?
I don't think it analyzes. I don't think it does NLP on the text. I think it just gives you. I don't think it validates the valid of the text, the values of the text, just the elements of it. I not 100% sure, but I think it's just a raw feed of here is the text that I located. But I can get back to you on that.
Does it do face ID? Like, can it pair me to? Like, does it know who I am?
No, and that's the difference between detection and recognition, and that's why I call it out. Recognizing you versus recognizing something with a face, and it's the latter more so than the former. It doesn't know who you are specifically, but it will find a face.
So if it sees a cat, it knows it's a cat.
It knows that there's something with a face. So 2 eyes and a mouth, typically human. It's not going to look for cat faces, as far as I'm aware. It's not going to look for animals. It's not designed for that. It's designed for framing yourself, basically, or other people. And like I said, actually this one, maybe it'll be better if I pull up on screen here. So let me escape, and I'll go ahead and I'll do that real quick. Any other questions, by the way? I'm more than willing to answer questions while things are going on. So.
Will the character detection? You said offline does Latin and online does more. Will it detect things like emoji as well?
I don't believe emojis are considered a language. And therefore, emoji text is probably going to be filtered out, more than likely. It may try to parse that, but so it's very dark here. Got a little light, maybe this is. So even in this horrible light, it's detecting that I have a face and I have 2 eyes, and not very well though. I'm not very happy. No, I'm up on stage, and but I can turn it around and not detect any faces in the room because of the size.
What does TensorFlow do? Like, oh,
Is that better?
The happiness is 0.2.
oh, now it's one.
0.96.
So you'll also notice that as I moved, it noticed that there was only a single eye in the screen. I can't look at everything.
Oh,
So
wait, that's interesting. If you did that, can you, yeah, it sees two features because it sees the video. It's also
it sees the video of the video, and it.
but it doesn't detect us two faces. Oh, it does detect us two faces. Okay.
So it's not very good. It's not doing any heat or thermal. It's just doing raw two-dimensional, and that's why it would work that way. That's a very interesting thing that I hadn't tried yet.
So the track faces across frames,
Mhm.
does it actually tell you, like, what does that mean? Does it kind of identify faces with some unique ID that tells you it's the same face? Or
So each face is given a bounding box, as you saw there, and so those faces would be given IDs, and that ID would translate through each frame. Yeah, that's part of the data that you get back from this API.
Can it detect your mood other than just a smile, knowing if you're not happy or happy?
That's a great question. I don't believe that that's currently available. I do believe that's part of what's coming, what they're extending it with.
Cloud Vision does it. I don't know about
This specifically does a small amount. Cloud Vision, as Nitya said, supports more, and that's again why they recommend that. They're bringing more of that deep. I think they're calling it deep contouring of facial detection. They're bringing that into MLKit. It's not currently part of it. That's the asterisk on the more to come that was mentioned at the beginning.
Right, like, one question would be, like, let's say you want to use an API like this for, like, let's say a 911 service. You know, what kinds of things could it do? Right? Could it determine, your vital signs? No.
the biggest problem is that it gives you confidence, and you have to figure out whether that's enough, and it's not always like the highest level.
Right, so it's just spitting out probability numbers.
Yes.
Yep, 0 to 1.
It seems like it's a TensorFlow Lite. It's just giving you the
Almost everything on device will be considered TensorFlow Light. Essentially, they're all of Google's hand-built models around these things.
Basically, it's just Google Vision taking a picture and running it through TensorFlow and spitting out a result.
For on-device and most of this, yes, even on cloud. And that's why one of the options here is the ability to do custom TensorFlow models as well through MLKit. It's just the ability to register and add and leverage. So just for those who didn't notice while I was speaking, went ahead and added text detection on the screen here. So as you can see, it's going very text heavy on me. But the keyboard, I get caps lock and shift, and they do a pretty good job of overlaying them on or near where the buttons are. And again, given the restriction on the amount of data that can return, we're finding things shifting and moving around based on how well it can detect that. And this is again live feed, all on device. Face detection is not something that is supported in the cloud. Just got to double check that, make sure. Next up on our API journey is barcode scanning. Barcode scanning. This also executes on device. It reads most standard formats, your standard 2D as well as 1D, I guess, the standard UPC and ISBN barcode numbers, things like that. I can't list them all because I don't know them all. But QR codes work, matrix codes, Aztec codes, all of these fun barcode scans. The best part about them is that there's automatic detection, but you can scope them. If you know that you're looking for a QR code, there's no point in trying to read any other UPC code. So you can limit it to just QR code detection. There is one minor caveat, and I believe that that's the matrix, the 2D matrix images are designed to require centering that image, so you can't have more than one per image, and it has to be centered. I don't make the rules, I just repeat them. It's just the way that the format works. I would think that it's something that might have machine learning, might be able to slice up an image better once it detects that one's in there, remove it, and maybe find another. But that's just me musing there. It'll extract structured data from the response, so things like Wi-Fi data. I'm sure you've seen those QR codes that will connect you to a Wi-Fi connection without telling you explicitly what the password is or what the name of the network is. This will parse that into the correct structures for you. And like I mentioned, it works in any orientation, upside down, so you don't have to worry about how that image is given to the model. But they still, recommendations to always pass it in right side up. And so moving back to the camera, I think this will never tell where the mouse runs off to. There it is. So for barcode scanning, that's text and that's barcode. So I got a lovely bottle of water up here. And that looks to be the number. That's pretty standard for barcode. I had a QR code somewhere. Don't know where that went. Now, and the last API to talk about would be landmark recognition. Landmark recognition lets you know about well-known landmarks. This is an in the cloud only execution, meaning you can only send this up to Google to define for you. The data returned gives you the name and geographic coordinates, and it detects the region within the supplied image. So you know where in the image the landmark that was identified is located. The Eiffel Tower is a great example, of course. This one's a bit harder to show you in person because I'm not near any big landmarks. Yeah.
Does it detect only based on location, or can it detect on?
It'll actually detect from a picture as well, which is why I haven't actually tried this. So this will be me doing this in person, but I do have. I'm not gonna show you my screen yet on this phone because I don't want you to see all my photos. But I'm gonna unplug this and grab a picture that I know is out there. What? I have that's not going to help me, a landmark picture from Android. Everyone knows where Android Summit is taking place, right? I guess that might not. I will get back to you on that one. How's that? I was not ready to show landmark for a number of reasons. My apologies on that. The thing to take away here is it's very similar to some of the other APIs that you've already seen. It'll give you the bounding box, the landmark within the image. It'll let you know where it is. It'll give you information about it. The big thing about everything that you've seen here, you get Google Knowledge Graph IDs for anything that it detects. And for those of you who don't know what Knowledge Graph IDs are, you're new to machine learning, Google has an explicit node list that aligns with everything that it gives you. So any model value that you get back out of anything that you've seen here, it correlates to one and only one thing inside of the Google design model, machine learning model. And those links and those IDs come back here. It gives you language independent information about what was detected, regardless of the physical or textual description supplied in any language. So it's language independent, which is great because you get reproducible results. You know how that could have been triggered. It helps you to build and learn models off of this. So those are the 5 ready-to-use APIs. The overview: image labeling, text recognition, face detection, barcode scanning, and landmark recognition. And just to visually, here's what runs in the cloud and on device. You'll notice I have some frankenphone of iOS and Android because it runs on both iOS and Android. And just to call it out, landmark recognition only runs in the cloud. Image labeling and text recognition, you get more functionality when you run it in the cloud, but run both on device and on the cloud. And face detection and barcode scanning are done in real time on the device. All of these models, of course, are updated, but wait, I think I missed, I missed TensorFlow Lite. So TensorFlow Lite actually runs on the device. And so that's another thing that you can do. And TensorFlow Lite, for those who are unaware, are your custom models, the things that you've designed and built that work better for your scenarios than maybe Google's. Maybe your models know that certain words are expected more so than others, and so your text recognition or your will apply more so for your domain than, say, Google's generic text identifiers. And so TensorFlow Lite, for those who don't know, is how you would address some of that. And so they can be bundled or hosted in the cloud. So you can either include those TF Lite files with the actual APK, or you can send them, download them at runtime. And they also have auto-download models. So if you host them in Firebase or on the cloud, you can write parameters as to when devices should update their local cache of those models. I will say that if you are using, you can use a combination of local and cloud. If you are using, if you're pulling down the data from the cloud-backed portion of it, that it will require, it will always fall back to your local if you're not on the network, or if it can't connect, or the SLAs don't exist.
Do you know if you can train your models with live data? I mean, it's not live, but at least like if the user interacts with your app, you send that data, have a new model generated, and come back.
I'm almost sure that that's not possible. You may be able to send performance analytics up, but I don't think that there's a way to train it. You can keep those data models and then send it up to the cloud to your TensorFlow model to do that. The thing to keep in mind here is we're talking about the reason why it's considered light is because it calls some of the tree for you, and it gives you a file that's reasonable within a mobile device. Obviously, what we consider reasonable keeps changing, hence the download limits that keep going up. But in reality, it's really designed to get you there as close as possible while still being able to download updates at runtime if you so choose. There are some other minor caveats here, and that is unless you're using a newer version of Android, API 21 or higher, I think that would put you in the lollipop range. There is the possibility that these files could be leaked outside of your application space through backups and things like that. So keep in mind, you probably want to, if you want to keep your models secure, you're probably going to want to use something newer and targets newer versions of Android, just to prevent those from getting out there. So this next half is embracing, sort of the how-to of integrating MLKit into your projects. Question?
So just quick, because I don't know if you'll cover it later, TensorFlow Lite, you can upload your custom models to the backend, right, of Firebase?
Yes, they can be your TF Lite files, the actual models can be hosted through Firebase, and they can be downloaded at runtime.
Yeah, so that's what I was going to ask you. You have this thing that said auto download. So does that mean that when you upload it, it gets pulled down for you automatically into the app that associated with that?
You can configure those parameters as to when it should download, whether it's on Wi-Fi, whether it's plugged in, things like that. It'll continually update based on the parameters therein. It's not a one-time thing. It's every time that it detects an update and it meets your update conditions. Like if you know that your model's substantially large, even in TF Lite, you'll probably want them to be on Wi-Fi. you could use remote config for the parameters inside the update to the update parameters of downloading the new models. Yes, that would be a possibility. See no reason why that wouldn't apply. But it's a great question. Step one, getting the dependencies, getting MLKit into your application. For Android, as we all know, that involves Gradle. And so you just add in ML Vision. The current version is 17. There's one other, if you were doing image labeling, you need another one. It's this ability to get the models for all of the labels, the 400 plus that they talk about. They're currently at 15. Obviously, these change as new versions of libraries release. I wrote this down, and they're going to release a new version tomorrow, so this is already out of date. Optionally, you can also add in this call, this metadata call into your manifest file. This optional call forces a download of the most recent models for face, text recognition, image labeling, and barcode scanning. And the reason for that, if you put it in your app manifest, it'll download after installation from the Play Store. If you do not put it in your app manifest, this is why it's optional, it will only download after the user attempts to use it. You won't get any data until it's finished downloading, but it's an on-demand sort of thing as opposed to once the app is installed. So if you're trying to make sure that your user, being good stewards of the user's data, you would want to make sure not to include this. Then, of course, converting the image. So there's 4 ways, because you need a Firebase Vision image object. First one's from a bitmap, pretty straightforward. So I have Kotlin code on here, for those who don't know. If it's bad Kotlin code, let me know after the fact. All of the examples on the web are all Java at the moment, and even their sample project is written in Java. So I spent some time trying to make this Kotlin-ish. It did compile, so there's that. I just didn't know if it actually worked. Like I said, I write bad code, so I break code. From a file, so you can include the image with your application. You can download it from the web. They're also from a media image, Camera API 2. Is how you would do that. So you can do the live stream, and you've seen this. I will say that you have to, you'll notice that there's a rotation parameter that you pass in. I will say that the camera is the worst when it comes to working with Android. Even API 2, which makes it better, is still worse than anything else. And then, of course, from a byte buffer is another option. Again, the metadata that you build supplies a rotation of the image that needs to be applied so that it's right side up, if you will. And then, of course, using detectors. Now, I'm not going to go through all of them. I'll explain the common pattern here, and then I'll show you the barcode scanner. You set the options up, and they vary depending on where you're executing. I mentioned earlier things like setting the threshold when you're on device for image labeling, but being able to return more than 15 results when coming from the server. The defaults can be used, and you can simply not include the parameter when you go to get an instance of the detector. And then, of course, you obtain said detector. So typically in Android, there are Firebase Vision barcode detector, Firebase Vision image label detector. The list goes on. You then call detect an image on the detector and pass in your Firebase Vision image that we created in the previous step, and you handle the responses. Simple. That's horrible. So I'll go through. This sets up the barcode option to only look for QR codes. It then pulls a detector with that option, so that detector will now only detect QR codes. And then it calls the detect an image on the incoming image. I have an extra parentheses there. It's wrong. We add an on success listener for the list, and in this case, we log out what the raw value of that barcode we read was to logcat. And if there's a failure, we do something, I assume. And And that's just an example of how the barcode scanner works. All of these work very similar. You would do this, something very similar, pass in your options, build your options object, go into the detector, and then detect an image. Oh yeah, right, TensorFlow Lite. You guys probably care about that. So the reason why that's not included in the previous section is TensorFlow Lite works on your models, and your models aren't all vision-based. And so the dependencies for TensorFlow Lite are just the ML model interpreter. In this instance, your model interpreter is used to load the TF Lite files and to execute your TensorFlow models. If you are including it with your locally or in your APK, you want to make sure that AAPT does not compress that file, the TF Lite file that it gives you, so that there's this no compress option if you're including that as an asset. Dependencies for TensorFlow require this model interpreter. The local source, so you have to register your model with the model manager. You can, I'd mentioned earlier, this only shows local mode, but there's the ability to set a remote model name as well in this, so it knows what to pull down. It tries to pull it down and use it. And then, of course, the interpreter gets an instance. So this is just configuring it and getting it up and running. You specify the parameters. Now, Firebase doesn't really know what your model takes as input and what it provides as output. And so you have to make sure that you define that for the users so you can use this. In this case, the inputs are byte data, and the output is a float 32. Multiple arrays, you know your data models. It's all binary based. I should say it's byte, int, float, long, and similar for input and output. And so you have to let it know what it's expecting when you before you execute, which is obviously what you do at this point. And so you add your input, and then you send it out, and you process success and failures based on that. It's the same pattern for everything. And TensorFlow Lite is no different. It's simply that you've defined the input, and it's not vision-based. So to summarize, MLKit brings powerful machine learning models to iOS and Android. That includes Android things. You can actually run MLKit on IoT devices. There are more models on the horizon. I spoke about this. Smart Reply is one of them. They actually provide the TensorFlow model as a TF Lite file for Smart Reply at the moment. So you can actually sort of play with that beforehand. It's Android only right now, though, which I find mildly amusing. And enhanced face detection, which we talked about earlier, the contours and more than just happiness. Dealing with the Camera 2 API is very difficult. It's actually, I mean, it's not as bad as the original Camera API, which we all know was horrible, but it's definitely harder than actually using MLKit. So trying to get images and trying to rotate them correctly, while you only need to do that once, it's probably the hardest thing you will do whenever you integrate MLKit. And then, of course, TensorFlow Lite for those things that are missing. It's not just the models, but you can actually go and build a custom TensorFlow implementation, new methods, custom methods, things like that, and that supports that. I just didn't go into that level of detail. If you are really interested in that, I can get you that information. One of the other things I will discuss, I skipped in these slides, but everything I showed you has a corresponding Swift slide within the actual deck. So the presentation that I give to the organizers here will include those slides as well, so you can see how to integrate this on iOS and not just Android. And that's it. Thank you.